well, learners. I welcome you all to the third lecture in the lecture series of Database Management System. In my last lecture, I discussed with you what is views and how views can give some extra protection and security to the database. Also, I discussed with you why file-based system was discarded and why DBMS or Database Management System was adopted in its place. In this lecture, we are going to discuss instances and schemas. What are instances and what is schemas? And then we will discuss three-tier architecture of database management system. And then we will see a very interesting concept called logical and physical data independence, which is followed by DBMS. So let's start.
So, what is schema? Before I go to schema instances, these are nothing but some terminologies. Okay, so these terminology you must understand or you must know once you are dealing with DBMS, because we often use these terms. So schema is one such term. Schema is nothing but the overall design of the database. Understood? Because once the design of the database is completed, that schema is hardly going to change. So the whole design, overall design, that will be called as database schema. Okay, then what is instances? Instance or instances. So database is nothing but it is always a ever-changing thing, because database change over time, because as we are inserting data into it or delete the data from it, naturally database is going to change. So the collection of those data which is stored at a particular moment, that will be called the instance of the database. And whenever you will be knowing the database architecture, then also you will be knowing that once an instance is created, then definitely some memory portion will be stored apart. It will be kept apart so that for each instance, there will be a separate portion of RAM which will be allocated. And not only that, several background processes also run with each and every instance. So remember, instance is nothing but the database which is changing with time. For that, the collection of the data stored at a particular moment, that will be called as the instance of the database. So if you have not understood this instances concept and schemas concept very well, let's take a very simple analogy. Suppose you are writing a program in a programming language. Now a database schema, it corresponds to the variable declaration, because variable declaration is must, because it is the first step in designing a program in the programming language. Once your variable has been declared, then the whole structure is ready. So the schema is that structure. It corresponds to variable declaration that you generally do in a program. So you have understood what is schema. But these variables will have different values at different point of time. So the values of the variables at a particular point of time, that will be called as instance of a database schema. That means it can correspond to an instance of a database schema. That means the values of the variables. So naturally, schema is the designing of database, and instance means the values which are stored at a particular instance, that will be called as instance. Okay. Now, we will be moving the most important part of today's lecture, that is three-tier architecture. See, whatever data items we are storing, that will be stored in the hard disk. But hard disk will be basically operated by operating system, and OS understands everything in terms of file. So whatever data you are storing in the database, that will be stored in the physical level in the hard disk in terms of files. So at the physical level, always the file structure, index structure, these are actually dealt with, because this level is responsible for allocating physical storage space to the data. Understood? And that's why this level is called the internal level or the physical level. Next comes the logical level or conceptual level. Now, logical level describes what data is stored in it and the relationship between the different data items. In the logical level, actually data will be stored in table structure. So, what are the table structure that will be created, that is decided in conceptual level. And also relationship among different data items, that will be also stored in table structure. And that's why this is called the conceptual level or logical level. Next comes the external level or view level. Here, actually, different users, they will be using the DBMS and database by using some views. View 1, view 2, view 3. You can see there are n users have been shown, user 1 to user n, and these users, they can view the desired data from conceptual level which is relevant for them, and this external level or view level basically deals with the application program or the views. So basically, whatever database you are creating, corresponding to each database, there will be a file system created. But as a normal user or administrator, we cannot get access to that actual file system. But for that file, DBMS creates some table structure for us. So whatever communication we are doing with DBMS, that will be done in terms of table structure. Understood? That is the main advantage of DBMS, because we are not dealing with files. So DBMS takes care of file system because OS understands everything in terms of files, and we understand everything in terms of tables very easily from our childhood. So what DBMS does, DBMS sits between users and the OS level, and DBMS translates our comments to the file system, to the OS, and again DBMS takes the answers from the OS, and definitely through conceptual level, DBMS then gives the answer to us in table structure. So you can see our input and output each will be done using this DBMS, because DBMS talks to us as well as DBMS talks to the OS file system. So these three-tiered architecture is very much important. Another thing that I want to discuss with you is the data independence. It means although there are three tier, as you have seen, that external level, conceptual level, or internal level, now we should have data independence concept to be implemented in DBMS, which means that if schema at any one level of the database gets changed, other levels should not be changed, should not be affected. That means we can keep data independent from the programs that use it by using this data independence. Okay. Now, data independence will be manifested in two ways. One is called logical data independence, another will be called as physical data independence. Now, let's understand what is logical data independence. It means that if there is a change in the logical level or conceptual level, some changes have been made. Maybe you have changed some table structure, we have changed some relationship status, but it should not impact the physical level or internal level and view level or external level. Naturally, our job becomes very much easy because only the changes will be done in the logical level, rest will be taken care of by DBMS. Another data independence which is manifested, that is called physical data independence. This means that even if some changes are there in the physical level, maybe index structure has changed, maybe file structure has changed, but that should not impact our next two levels, means logical level or view level. So these two are very important or very good feature of DBMS. That means logical independence and physical data independence, because data is completely kept separated from the program. Understood? So with this, I'm concluding my lecture today. Hope you have enjoyed my lecture, and in my next lecture, I will discuss with you about the data models. Okay, so stay tuned.